Hi everyone. My name is Benjamin. I think most of you knows me. Today we are going to discuss about earthquakes. All I want you to do is sit back, relax, and enjoy the lesson.
The earthquake is the violent shaking of the earth crust.
Well, to define an earthquake is when the ground shakes violently because a piece of the crust of the earth has suddenly moved. And a tectonic plate is a section of the crust that floats on the mantle.
Earthquakes does not happens anywhere in the world, but actually happens where the places along or located plate boundaries. For example, the Nazik and South America, it's an
The surface of our entire planet is made up of a number of moving plates. These tectonic plates fit together like giant pieces of a jigsaw puzzle. The cold, rigid plates move slowly over this hot, soft interior, just a couple of centimetres a year, but as they move, they grate and tug and get caught up with each other at the plate boundaries. And that's how earthquakes begin. It created an accurate map of the world's earthquake zones. And what was the significance of this map? Well, the earthquake lines revealed the hidden edges of the Earth's tectonic plates.
Earthquakes don't just take place everywhere in the world, but they actually follow the narrow paths of plate boundaries. So they take place along plate boundaries. And the second point is they only take place in the unstable zones, and that is exactly along the plate boundaries. You can also study the map very well, and then you can refer to specific places like the west coast of America, that is both South America and North America, Southern Europe.
Plates move in three different ways. Sometimes you'll find like plates moving towards each other, and this is where we call it converging plates or destructive plates away from each other. This is called the diverging plate boundaries. So you might find plates moving alongside each other, whereby one is moving.
Did you know that the inside of the Earth is made of hot molten rock called mantle? The crust we live on floats on top of this mantle. However, Earth's crust is not a single continuous solid land. In fact, it is broken in many pieces, like a jigsaw puzzle. These parts of the Earth's crust are called tectonic plates. The whole landscape around us is a result of the movement of tectonic plates. This movement can cause earthquakes, volcanoes, mountains, and trenches. Let me explain in detail. Land features such as mountain formations and events such as earthquakes happen due to the continuous movement of the tectonic plates. As these plates keep moving around the Earth's surface, they shape our world. As the tectonic plates move, they collide with each other. The plates can collide in many ways.
Now, on the movement of plates, if two plates move towards each other, they form a converging or destructive plate boundary. Here, if the two plates are different plates, like oceanic and continental plates, oceanic plate will be forced under the continental plate, and that will form a subduction zone. On the other hand, if you have two continental plates that move toward each other, there is neither of them that is going to be forced under the other one. So what happens is that they will lead into an uplift, and they will form fold mountains, example the Himalaya. And the place where, or the point where two plates move, continental and continental, move toward each other, this is known as a collision boundary. Sometimes plates can also move alongside each other. They can slide past each other, or they can go along each other, except that one will be much slower than the other one. This is called conservative plate boundary, or you can also call it neutral or shear plate boundaries.
The San Andreas Fault is one of California's most distinctive natural landmarks, a gigantic gash across the state. We now know that this fault is where two massive tectonic plates meet, and they're slowly moving past each other all the time.
So the third one that we are going to discuss is actually diverging plate boundaries. And diverging is so important because this is at the point where we can also have the constructions of new land. Apart from the other two, this is the only type of plate boundary that is not associated with earthquakes at all. Now, what is diverging plate boundaries? So diverging plate boundaries is where you have two plates moving away from each other.
The effect of the earthquake can be devastating. Buildings can collapse and kill people. Roads and telephone lines are destroyed underground water, leaving people without drinking water.
I went down to Nios. There was no people. Everybody was dead.
And hundreds were seriously injured. Gas mains burst and fires burned out of control for 3 days. The earthquake and its aftermath killed up to 6,000 people. Mountains and rivers changed places and roads were destroyed. A huge underwater earthquake ripped apart the seafloor northwest of Sumatra, Indonesia. When it subsided, no one had any idea that the tremors had generated something even more deadly, a tsunami. I watched these images, amazed at how easily people's lives and homes were swept away. The tsunami had hit the nearest shores with such force it rose to over 60 feet and surged inland for up to 3 miles. It destroyed everything in its path.
The summary of the effects of earthquake. First, buildings will collapse because the ground will start to vibrate. People that will be inside those buildings, they will be killed. Most of them, they'll get injured. Now, transport system, talking of roads, you're talking of railway, they'll be damaged. If you have dams around that place, dams, of course, will collapse, and then that will lead to flooding, and flooding will lead to loss of life and other damages also, like loss of properties. It might lead to landslide. Electricities will be cut off, fire may start, and then the water and gas lines will be broken. If it's an underwater earthquake that has just taken place, it will lead to tsunami.
You get a real sense of how plates move when you come up to a fault line like this. As the vast plates kind of slide past each other, they get snagged along their edges. When they get stuck, the pressure builds up along fault lines. Eventually, the strain gets so great that the fault ruptures, releasing huge amounts of energy, which shakes the ground for miles around. The Cascadia Fault lies on what geologists call a subduction zone. A subduction zone is where two giant plates meet head to head, and one of them gets pushed right down under the other. Subduction zones can produce the biggest earthquakes on the planet. Subduction zones cause earthquakes when the plate that's being pushed down gets stuck. As it pushes, the upper plate gets squeezed and distorted. Eventually, the strain becomes too much. The upper plate slips, and that's what creates a rare event, a megathrust earthquake.
Now a description of how earthquakes take place at the destructive plate boundary. Actually, it happens where you have continental and oceanic plates meeting. Oceanic is always heavy, so it always sinks under the continental plates. So when this is taking place, continental gets stuck on the sinking oceanic plates, and that increases pressure and friction to build up. And after some time, continental plate actually is released, and that causes the earthquake when the earth actually shake violently.
At the constructive plate boundary, this is simply when plates are moving apart from each other. When it's in the ocean and they start moving in the ocean, they obviously leave a gap between them. So magma will rise from the mantle to the ocean floor to replace the gap. So, and it will be solidified and a new landform will be created there.
Constructive plate boundaries is where you have two plates moving away from each other. When this happens, these two plates, they create a gap between them. Now, this gap must not be left alone. Nature has its own way of maintaining itself. Now, when that happens, magma from underneath will actually rise up, and then it will fill that gap, and then it will then cool down, and then it solidify as lava, and then it forms a new crust. In other words, it forms the new land.
It depends on the place whether it's an urban area or rural area. When the earthquake occurs in urban area, more death will be experienced due to the high population and the high building which can break easily. It also depends on the time which the earthquake occurs. When it occurs during the night, more death can be caused because people are sleeping.
The reasons why some earthquake might cause more destruction than others of the same magnitudes. If buildings are not made to resist earthquakes, there will be more destruction. If the magnitude is higher, that means the earthquake is very strong. That of course will lead to more destruction. If earthquake takes place in winter, most people are indoors. That means they are inside their houses during winter. So that will lead to more death because they will be trapped in those buildings. If a certain place have less resistant rocks, more destruction will take place. If the focus is very closer to the surface, that means more destruction also. If a place is closer to the epicenter, that will lead to more destruction. If an earthquake takes place at night, more people are sleeping at night, so the chances of escaping from building is very, very low. If it takes place in developing countries, for example, they have few rescue services. That will mean more deaths. And if it takes place in area with higher population density, the higher the population in a place, the higher the death that will be recorded.
So what can be done to reduce the impact of earthquake is to train a rescue team to be on alert. Most electrical wires must be buried to avoid fire. Always keep the first aid equipment close by and use latest technology to build more earthquake resistant buildings.
The earthquake, measuring 7.4 in magnitude, lasted just 45 seconds. In our next story, we'll see how innovative building design can save lives. And it turns out, surprisingly, that one particular kind of skyscraper might be the safest place to be when an earthquake strikes. Yet this is where developers decided to build the tallest skyscraper in Latin America. It's called the Torre Mayor. Mayor is probably the strongest building in the world, built to withstand an earthquake of a magnitude of 8.5. And over in Turkey, There's one fault where we think we can make an earthquake forecast. We think we know exactly where the next earthquake will strike, and that's an exciting breakthrough. The only trouble is, we don't know when.